Topographic wetness index. So what is topographic wetness index? The topographic wetness index is the most widely applied hydrologic topographic index, which describes the capacity of a cell to accumulate water. TWI integrates the water supply from upslope catchment area and downslope water drainage for each cell in a dam. The topographic wetness index therefore has three key components: total catchment area, flow width, and slope gradient. Topographic wetness index expresses the terrain-driven balance of the catchment, water supply, and local drainage. When calculating the topographic wetness index from the digital terrain model, all terrain sinks and flat pixels should be removed first. Then total catchment area, flow, width, and slope for each pixel must be calculated. Finally, these three components are integrated into the topographic wetness index according to the equation shown below in red. So this is the topographic wetness index. So it's a logarithm of total catchment area divided into flow width, and this is all. It's a fractional value which is with denominator of tangents of a slope. So this is one way to create topographic wetness index. So formula, it's ln logarithm in brackets specific catchment area divided into tangents of slopes in radians. So this is a scheme of topographic wetness index. So A flow accumulation area, so C, it's a flow accumulation area, and B flow direction and the corresponding flow width for a dam cell. So it's a flow width for a dam cell, and C, the tangents of the slope angle. So this is the tangents of the slope angle. So again, that flow accumulation area, and this is flow direction and corresponding, and tangents of a slope. Classification: areas susceptible for water accumulation and categorized by low slope angle will be represented by high topographic wetness values. At that time, well-drained dry areas associated with the low topographic wetness index values. The topographic wetness index is unitless. Application: topographic wetness index is primarily used to quantify topographic controls on hydrological processes. So this index can also be used to characterize biological processes, including forest site quality, vegetation patterns, and annual net primary production. So these are steps in order to create topographic wetness index in ArcGIS. So first we already create that field for digital elevation model. Then we will create flow direction, and from flow direction we will create flow accumulation. Then we already created a slope in degrees, but then we should convert it into radians using this formula. Then calculate tangents of a slope with raster calculator, so with this. And then rescale flow accumulation. So using this formula, flow accumulation plus 1 multiplied cell size, and the last one is this formula, so flow accumulation divided into tangents of a slope.